Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this Advanced Tips and Techniques video series. This is episode 18. Advanced Modeling 14, and we are continuing our discussion about the master model technique. And in this episode, we're going to pick up where we left off in our last episode, and we're going to talk about the advantages and disadvantages of the various four methods that I outlined. We'll also talk about how to overcome some of the issues that can arise with save bodies and other insert-derived methods where SolidWorks complains about fail to save document and naming this part's name already exists. So I'll give you a few tips on how to overcome those issues. And then we'll finalize with some additional best practices for the SolidWorks master model method. So just as review, master model is basically the ability to insert one base part into other derived parts parametrically. And it's used when, especially for consumer product design, when you have a main form that is the identity of the design, but you need to split it up into its various components for manufacturing. And you want to keep those derived various components parametric to the main form. And then all of it's actually reassembled into a main assembly, and the components can be detailed and drawings can be created, and a very successful method for how consumer product designers work. So we talked in our last episode about four methods for creating a master model workflow. And I'll just review these very quickly, and then we'll talk about each of them individually, their advantages and disadvantages. If you remember, you have insert to part push, where you right mouse button on the solid body in the solid bodies folder, and you can create a single derived part from that body. The second, which is like it, but you can do the entire base part by inserting it into a new part and then using the delete keep body feature to remove anything that's not relevant to that particular derived part. This is probably the most versatile method because you can actually bring in sketches and planes and axes as well as the solid or surface body. Save bodies is the most reliable of the four, and the one that I use the most because of that, and the ability to re-edit the actual stock feature, which is not easily done with either the insert part methods. The final is split part, where you want to split out a single body, usually from a base part that's going to be eventually used as the component. We talked about that a little bit in our last episode. So let's get into taking a closer look at the advantages and disadvantages of each of these methods. So the first method, the insert part push method that I showed really briefly, and I'll show it again. It's a simple single derive of a single body in the solid bodies folder. Very simple to do, very reliable to do. It's one body versus one part, which is less is more, meaning that you have less to deal with as far as all the bodies or all the features in that base part. It's basically associating one body to one part. The disadvantages of it, and this is a big one, is that there is no way apparently to edit the stock part. And I can show that here very quickly with our SoundDoc model. So let's say, for instance, we want to insert a part from this single part body, or the single body called power button. So we go ahead and we right click and find that command. We name the part, and I've already created it here, so I'm going to create another one called maybe temp B. And once we have that, we can apply the template, and we go ahead and save it. But you notice if you right click over this, you do not get the ability to edit it. You can only go and find it, but you cannot edit. You can go ahead and find the base part, but you cannot edit it. So that's a big disadvantage of this particular method. The second method that you can use for master modeling is the insert part method. And this is probably the most versatile of all of them, in that you not only can include the surface and solid data, you can also include sketches, axes, planes, and other reference features into your derived part. Also, at a later point, if you want to break the references away from the master part, you can do that and then reinsert all of the features that were created in the master part into the derived part. This, as far as I can tell, is the only of the four that you can actually do this and have it be successful. Let me show you with our SoundDoc model how we can use the insert part method. So if we open our SoundDoc model and then immediately go and create a new empty part, and I create a new metric empty part here, insert part, and that part will be our master model. So we can choose to actually relocate it as we move it in. I wouldn't recommend that. I'd use the same coordinate system. But we can also here, as you can see, not only include the solid or surfaces, but axes, planes, absorbed and unabsorbed sketches, along with coordinate systems and other model data into our derived part. So if we do that and go ahead and accept it, we see that now that we have our base model, and we have folders that include various references, like all the planes and then the unabsorbed sketches. Now, usually with this method, let's go ahead and hide all of these, so it just makes it clearer. We can usually in this method you need to also employ another feature, and that's the delete keep bodies, so that you remove the bodies that aren't relevant to this part. And let's say we can just go ahead and save this as we want this to be the front housing. And with that, we immediately want to open up our solid bodies folder and find our front housing, hit your delete key, and then make the choice keep bodies. So what this is going to do is it's going to keep the front and then delete all the other bodies. Conversely, if you wanted to actually delete all the other ones and keep this one, then you'd hit delete bodies and then select everything but the front housing. But it's probably just more reliable to just keep that one body that's relevant to this particular derived feature. So if we do that, now you can see that we have just our front housing, and then from this point we can do further detailing in this part. So also you notice that the stock feature itself is editable, and but really all you can do is you can't edit back to the actual master model like you can with save bodies and split, but you can just really redefine what is being brought in. So it's rather limited in that standpoint. If you use this method where you're just bringing in this base part and then use the delete keep bodies, usually it works for you. So, and then you get the added benefit of having the other features there. Now the disadvantages of the insert part method are that you not only can you not edit back to the master and reassign bodies, it's not as reliable as save bodies or split part, because it has a tendency that when the master changes and anything with the master's body, if it's a split or it's a combine of other bodies, it will likely fail this incoming body that you selected. And so you're going to have to, when significant changes happen in the master, you'll have to go back to this delete bodies feature, edit it, and then reassign to the correct body. At least that's my experience. So just wanted to point that out, that it is the most versatile, but maybe less reliable than the other methods. The save bodies method, which is our third method, is a method where you actually employ a derive feature in the actual master model called save bodies. And with that feature, you derive one body derive one body to one derived part, and that's all you're really doing. It's, again, as I mentioned before, it's the less is more. It's less to go wrong, actually, and that's what makes it very reliable. In addition to that, an advantage is that you can edit the actual stock feature to bring up the master model and then reassign the body to another body in the master model. You can also reassign the stock feature of the derived part to an entirely different master model, which makes it versatile and makes it useful for correcting issues with the master model method. And it also automatically can create your main assembly of derived parts when you create that save bodies feature. The disadvantage over the others is that it really only derives out a solid body from our body, a solid body or surface body from that single solid body. And I stand corrected there, actually. It only derives out a solid. It cannot derive out a surface. And you cannot reinsert all the features from a base part back into the derived part like you can with insert part. Although I think that's really an edge case, and I don't find a lot of reason for doing that. So we reviewed this a bit in our first episode. Let's do it again. Here we have our sound dock model. And again, if whatever bodies you have hidden will not be included when you initially bring up the save bodies. Let's go ahead and do an insert save bodies. And as I said before, it identifies just the bodies that are shown as being something that you want to derive out. You can click on the various bodies in your scene graph and then assign them individually, or you can hit the floppy disk icon and assign all of them at once. You can also assign a assembly to that. So we'll say sound dock main assembly. And you have some other settings down here. You can override the template with maybe your custom company template, which I do here. You can also propagate out the visual properties. I usually don't do that, and I usually don't consume the bodies. I leave them there. So there we have some features that we can use to do save bodies. If we save that and wait for each of the parts to be rebuilt into their own derived part, we'll eventually see our derived parts, but we'll also see the main assembly. If you click down into here, here's our main assembly of derived parts. And we can see here that each of them has been fixed in place, and you can float them obviously if you need to start doing some other things with them. So that is the save bodies method. Find it to be very reliable. The reason, as I mentioned, if we go into one of the derived parts here, we have the ability to actually edit the stock feature, which will take us back to our master model. And if we want to, we can reassign the body to a different body. So if we rebuild, we see now we have the lower housing instead of the front housing. So that's what makes it so useful. And this, of course, is useful when the master changes in such a way that it loses reference to that body. This is called the pull method. I'll talk a little bit more about that. And then we have the push method, and I'll talk a little bit more about that. Our fourth and final method for master model methodology is the split part method. And its advantage over the other ones is, especially save bodies, is it can derive out a surface body, whereas a save bodies can only derive out a solid. So if you need to do that, this is maybe a good choice. It's also robust like the save bodies in that you can edit the stock feature and you can redefine it to another master model or the same master model but a different surface or solid body. Its disadvantages are like save bodies in that it really can only derive out a surface or solid body but not sketches, planes, and other reference features. And unlike, also like save bodies, you can't reinsert all of the base features that were used to create the geometry back into Derive. In all fairness, it really does what it says here in that if you try to do this and break references with the base part, it just reinserts the stock part. But that's really, I don't think, what users would intend if they were to use it. Now, I mentioned in my last episode that master model is not necessarily just for consumer product design, but can be used in all types of industries that SolidWorks is used. I find it particularly useful for mechanism design. The reason is that you can build your mechanism in context of a single multi-body part file, and that makes it super convenient for mechanisms that and parts of mechanisms that are related to each other very closely. And then you can use the move copy feature on that body to just temporarily move it, see how it moves, how it relates to other things in a somewhat crude method. And then once you think you have the mechanism designed, you can then save bodies on it and derive those parts and then back into assembly. And then once those are in the assembly, then you can apply mates and motion mates to those to see your mechanism work properly. The big advantage there, of course, is you're using master model to separate the design of the part from the motion of the part. And that's super important, because if you were to try to do this with a totally in-context assembly design, you'd find that it doesn't work. And master model is great for separating the part from the motion of the part. And that's essentially why it's good for doing motion mechanisms. Now, when it comes to editing your derived or master model, there's two general ways of doing that, and they're called the push and pull method. The push method simply is editing the save bodies feature in the master and changing its association to a derived part or another derived part. And I'll show you that in a moment here. The pull method is the ability to, from the derived feature, to be able to edit its stock feature and then reassign its stock feature to another master model, or in the same master model, a different body within the saved bodies. So let me show that to you. And again, we'll bring up our sound dock model here. And here we have our sound dock, and we have the saved bodies here. We also have one of the parts, or two of the parts that are brought up. We have basically our original front housing, but I went ahead and saved another version of this that is called front housing Rev 2. And you can see we've added a few more features in here. And now we want to reassociate the save bodies feature with this new version of the front housing. Now, if you're to do that, you have to first remember that you can't have this in SolidWorks memory when you do that. If you do, it's going to say it can't overwrite it because it is in memory. So I'm going to go ahead and close this part out of memory and then go back to my master model and edit my save bodies feature and bring that up. Go and find the front housing, and here it is right here, and double click on it. Now, when you double click on it, you have two choices. You have an existing file. These are the files that are in memory, and you can reassign it to that front housing. That's not what I actually want. I want to actually assign it to this new version. So I'm going to go here to the new file, and this is somewhat of a misnomer because it isn't a new file. It's already existing. It could be a new file, but in this case, it's another file. I think is a better acronym. So I'm going to say a new file, and I'm going to browse for that. So I'm going to go find this front housing Rev 2 and go ahead and save it as the new body that's derived out. And what's really important about this is you have to remember that's so powerful about this is that this does not overwrite that file. It just overwrites the stock feature in that file. So if I were able to just continue with this and save it out along with everything else that's in here, and then go ahead and bring up that second version of the front housing, which is right here. We can see it's rebuilding because it just replaced the stock feature and it left the other features intact. So that's really powerful. That's really important when it comes time to start doing some significant editing on your master or your derived parts. Now, the push method is different from that in that if you don't have access to the master or you're not the author and you actually want to, from the derived part, you want to affect it, you can right click on the stock feature and go to the edit feature. When you do this, it's going to bring up the master model. And at this point, you can actually edit to another master model. I don't have one here right now, but you can do that. That has a Save Bodies feature in it. Or you can go to the Save Bodies feature that's in the current master, and I'm going to reassign this to another body. So instead of front housing, I'm going to make it the upper housing. And when you complete that, you can see that it's now a completely different body. Now, of course, these features failed because I've changed the intent so drastically, and these are not even on the correct plane to extrude up to the body. But that's how you would use what's called the pole method to edit the stock feature and go into the actual base feature. Now, occasionally there are issues with using Save Bodies, and anybody who's used Save Bodies for a while probably has seen these issues. Namely, there are two. There's one where when you go to name your derived part, it says it already exists, even though you know it doesn't exist, or at least you're not aware that it exists. And then the other is the fail to save part, and I'll cover each of those in a separate slide. Let's start with when it gives you this error, the document named front housing is already open. Please choose a different name. There's another error that's similar to that in that it won't allow you to save the name because it asks you to choose a different name. First of all, it's probably because there is another part called front housing that you're not aware of that is maybe in a different directory or is in memory. So there are a number of things you can try here, and I'll just have you try these if you have this issue, starting with the first issue and working down the list to the last issue or last suggestion. So the first thing you want to do is exit out of SolidWorks and make sure that there are no other occurrences of that file. And you can look for that when you have your Windows Explorer set to show hidden files. And if the file has a tilde symbol in front of it, that means that it's in session still. So you want to delete that occurrence of it once you're outside of SolidWorks. The next thing to try is just simply not only exit SolidWorks, but exit SolidWorks and reboot Windows and then go back into SolidWorks and try it again. If either of those don't work, start to look at your system options in SolidWorks. In system options, you have an option there that is called File Locations Reference Documents. And there you can list a number of areas within your local system for SolidWorks to go look for reference documents. If you just make sure that that list isn't pointing at folders where this supposed front housing is living, or just disable that. You can go to also System Options External References and uncheck mark that option, or uncheck Include Subfolders, which will limit where SolidWorks can go to look for that file and not complain at you that it already exists. The second issue that occasionally I run into is the fail to save document. And it gives you a path to your Windows SolidWorks install folder. And there are some things you can do to check on that. And they aren't very apparent, but I've found that if you can go down this list, you can probably eliminate this problem. The first thing to do is to check the actual part, the master part, and make sure there are no errors in it. This error, fail to save, can sometimes be triggered by something false or faulty in the part itself. So just make sure it's clean. You can use the evaluation check to check the solids of your part to make sure there are no errors. I would do that first. The second thing you can do is Make sure that your SolidWorks install directory has write permission. It's not just read only. Sometimes when you get the fail to save and it shows the path of your SolidWorks install, this could be the issue. Excuse me. And then make sure that the path to the derived part that you're trying to name is less than 255 characters. I know that that seems excessive, but sometimes you have it buried down into a subfolder that could include 255 characters, including the path folder names. This one I've seen occasionally. If you're using GrabCAD, actually kill it or close it or close out of SolidWorks, sync your parts, and then relaunch SolidWorks. GrabCAD is a quasi PDM system that caches files in a kind of hidden folder that you cannot see, and that could be the cause for it failing to save. Like the first error, try exiting SolidWorks and then rebooting Windows and then relaunching SolidWorks. This could remedy the problem. And then if all that fails, try, and this is the last resort, is to actually rename your master part to some other name and then use the pull method to reassign your derived parts. That is, go into each of the derived parts and pull the master model and reassign it from there. That list should probably solve the fail to save issue from what I have run into in my personal problems with this particular issue. That should correct it. A few other best practices for master modeling. If you do decide to do a pull method, that is where in the derived part you edit the stock feature and repoint it at another master model, just be aware that if you regenerate, the actual stock name is not going to change. Now this is by design because SolidWorks allows you to rename any feature in your feature manager, and the stock master part is just another feature. As you can see here, this stock master part 1 is not actually the right master. It's actually, if you do a right click on the part name at the top of the tree and go to external references, it shows that it's actually master part rev 2.1. So just make sure as a good housekeeping practice that if you do that, just re-edit the name of the stock master to reflect the actual new name of the master. So that you won't get confused or others won't be confused with that. One thing I see happen sometimes when you do a pull method, that is you edit the stock feature and go to the existing master, is that you cannot see the actual solid body in the preview, as is the case here for this front door panel. I go and pull it and I can't see it or pick it within the Save Bodies feature. If that's the case, the only thing I've found that you can do is really just exit out of that, close the stock feature, the derived part that's in question, and then go do the push method. That is, go into the actual master, edit the Save Bodies, and reassign it to the derived part, in this case, the door front panel that you want to be reassociated with. So that's a method for overcoming that. Some other best practices would be just the organization of your master. Once you're finished with your master and it's ready to just be derived to other parts, and you're really in a detailed design mode where you're just making minor changes, organize your master so that it reflects the way that you're building parts. And you can see this here in this particular master, that every folder contains essentially the features that are used to create that eventual derived part. Also, as you can see, that the actual solid bodies are named for their derived components. And then make sure that if you have any, this is really has nothing to do with save bodies or master modeling, but any features you have in there that are suppressed and you want to keep suppressed, please rename them or append on to the feature name, keep suppressed or to be deleted. And you could do that with the folders themselves too. Towards the end of the master model, go ahead and do a delete body on any stock features or other features you don't want to derive out. This just keeps it much easier when you go and edit the saved bodies, that you're not pulling up other bodies that are part of the derived bodies. It reduces the complexity and number when you have to edit. And then, of course, the save bodies feature is the last feature in the master, or it's near the last feature if you have other features beyond that that you don't want to be included in save bodies. So those are some good ways of organizing your master. If you want to learn more about master modeling than what I've talked about here, you do have a tutorial that's built into SolidWorks for looking at this issue of master modeling. You can get to it by clicking on the help icon in your session of SolidWorks and then go to the SolidWorks tutorials, and then from there go and choose the advanced techniques, and then under that, molded product design is the one you want to show a simple example of a mouse and how you would use the three different methods that I've described here for doing master modeling. So I hope that really helps in doing your master model method and brings to light maybe some issues you've been having with it. It's a very powerful tool for especially us consumer product designers, and so glad it's in there and so glad we have the different ways of doing it.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.